Okay, today we're going to talk about how to solve conversion problems and how to do one-step conversions using unit conversion factors. So this first key question is what happens when a measurement is multiplied by a conversion factor? And we use conversion factors every day in everyday life. We know, for instance, as far as in our monetary situation, we know that 4 quarters are a dollar, 10 dimes are equivalent to $1, or 100 pennies are equivalent to $1. But it's a lot more convenient to walk into a store and carry a dollar bill versus 100 pennies. However, they all um, express or have the spending power uh, of the same amount. So the same thing in can be said of scientific quantities. This example is a meter, which is a little further distance than a yard, can be 1,000 millimeters, 10 decimeters, or 100 centimeters. That's still the same distance. It's just how it's subdivided. So likewise, 1,000 grams is a kilogram. 10 decigrams is in a kilogram. So that's, again, you just have to look at the prefixes to know how many are present in the base unit. So whenever we have two measurements that are equivalent, we have what are called, it's a ratio, and it's called a unit equality. And this says, for example, you can divide both sides of the equation. 1 meter is equal to 100 centimeters by 1 meter or by 100 centimeters. They both would equal 1 when you do that. And that's called, again, a unit equality. So the conversion factor is a ratio of equivalent measurements. 100 centimeters in 1 meter, or 1 meter is equal to 100 centimeters. That is what's called a conversion factor. The definition of conversion factor is going to be something important. And you will have a table of conversion factors that you'll be allowed to use on any exam. And that includes when we get back to school and you're taking exams. And if we have a final at the end of the year, that final exam, you'll be given a table with several conversion factors on it. You're not expected to memorize all of those, but you're going to be expected to be able to use the conversion factors when they're given to you. So the measurement in the numerator is equivalent in, if it was, say, let's go back, or we can look at this one right here, is equivalent to the measurement in the denominator. So 100 centimeters has to be equal to whatever's in the denominator. And we know that 100 centimeters, that distance, is the same distance as 1 meter. So the conversion factors shown are red 100 centimeters per meter, and this one is red 1 meter is in 100 centimeters. I'm sorry. This figure above illustrates another way to look at the relationships in a conversion factor. The smaller number is part of the measurement with the largest unit, and the larger number is part of the measurement with a smaller unit. So we know 1 meter contains 100 centimeters. And this is just showing the entire meter stick can be subdivided into 100 centimeters. A centimeter is about the width of your finger. Okay, second key concept, when a measurement is multiplied by a conversion factor, the numerical value, this is important because this is kind of hard to wrap your mind around, the numerical value is changed, but the actual size of the quantity remains the same. So, for example, even though the numbers 1 gram and 10 decigrams differ, both measurements represent the same mass. One foot or 12 inches are the same distance, but the numerical value is different. In addition, conversion factors within a system of measurement are defined quantities or exact quantities. Therefore, they have an unlimited number of significant figures and do not affect the rounding of a calculated answer. And we saw that yesterday. Here are some additional examples of pairs of conversion factors. We can skip that. Okay, what is the relationship between the two components of a conversion factor? The two components are equivalent measurements with different units. They are two ways of expressing the same quantity. So, 1,000 grams, 1 kilogram. 1,000 millimeters, 1 meter. 1,000 meters is equal to 1 kilometer. You have that metric unit table from Friday that you can refer back to that have all of those units and the power of 10 that were in each of those units to refer back to. So, what kind of problems can you solve using this process called dimensional analysis? Let's stop here and we'll take a break and do a little Pearson activity.